Welcome to month one of the Tech Year track. You've spent years getting good at building things. This track is about learning to decide what to build, how to communicate it, and how to get organizational buy-in. Today's topic is strategic architecture, the intersection of technology vision and business reality. Think about this. How many of us have had a great technical idea that never got implemented? Most of us have, and the reasons are usually the same: no budget, leadership didn't understand it, or other priorities took over. Those aren't technical failures, they're communication failures. Today we'll fix that. The jump from senior engineer to tech lead isn't about writing better code. It's about making better decisions and communicating them effectively. Tech leads who can present a roadmap to the CTO, write an ADR that onboards new engineers, and run a due diligence review are rare and valuable. Today you'll learn to produce 4 deliverables that you'd actually use in a real tech lead role: a roadmap, an ADR, a due diligence report, and a stakeholder presentation. We have 4 major topics to cover. First, technology roadmaps, how to set direction. Second, architecture decision records, how to document the why behind decisions. Third, technical due diligence, how to evaluate systems you didn't build. And fourth, executive communication, how to translate technology into business language. The challenge ties it all together. You're the tech lead for an e-commerce company expanding internationally. You build the roadmap, make the architectural decisions, evaluate the platform, and present to the CEO. Let's start with the quote on this slide. The best tech leads think in years, not sprints. As a senior engineer, your planning horizon is a sprint, 2 weeks, maybe a quarter if you're thinking about a feature. As a tech lead, your planning horizon is 1 to 3 years. What's the technology landscape in 2 years? What technical capabilities does the business need by then? How do you get there without stopping feature development? There are 4 strategic responsibilities to understand. The first is setting technical direction. This is your technology vision, not a 50-page document, a clear answer to where is our technology going and why. Every engineer on the team should be able to articulate the direction in 1 sentence. The second is making architectural decisions. Senior engineers make implementation decisions. Tech leads make architectural decisions, the ones that are expensive to reverse. Which database? Which communication pattern, monolith or microservices? These decisions shape the team for years. And here's the key insight. Architectural decisions are not just technical. They're also organizational. Choosing microservices means choosing independent teams. Choosing a monolith means choosing coordinated deployments. The technology choice is an organizational choice. The third is aligning tech with business objectives. Your CTO doesn't care about your tech stack. They care about whether you can ship faster, reduce costs, or enter new markets. Your job is to connect every technical decision to one of these outcomes. If you can't explain how a technology change impacts revenue, cost, or risk, it won't get funded. Full stop. The fourth is communicating strategy to stakeholders. Stakeholders means everyone: your team, your manager, other tech leads, product managers, executives. Each audience needs a different message at a different altitude. To your team, we're migrating to Kubernetes for faster deployments and better reliability. To your CTO, Kubernetes reduces our deployment cycle from 2 weeks to 2 hours, unlocking 6 additional feature releases per quarter. To the CFO, Kubernetes migration costs $200,000 annually in infrastructure costs. Same decision, 3 messages, 3 altitudes. A technology roadmap answers 4 questions. The first question is, where are we today? This is your current state assessment. It needs to be brutally honest, not where you wish you were, where you actually are. A common mistake is that tech leads paint a rosy picture of their current state because they're embarrassed by the tech debt. Don't do that. Acknowledging reality is the first step to changing it. A proper current state assessment includes a tech stack inventory, known tech debt, team skill gaps, deployment frequency, incident rate, test coverage, and infrastructure costs. The second question is, where do we want to be? This is your vision, the 12 to 18-month target. It needs to be specific enough to be measurable. Better infrastructure is not a vision. deployment frequency from weekly to daily with zero downtime deploys is a vision. The vision should inspire but not hallucinate. If your team is deploying monthly, targeting hourly deploys in 6 months is fantasy. Monthly to weekly is realistic. The third question is, how do we get there? This is your path, defined by quarterly milestones. Each milestone should be a meaningful checkpoint that delivers value, not just phase 1 research. A good milestone sounds like Q2. Containerize the 3 highest traffic services. Deploy to staging via CI/CD. Result. Deployment time drops from 4 hours to 20 minutes for those services. A bad milestone sounds like Q2. Learn Docker. Learning isn't a milestone. Delivering value is. The fourth question is, how do we know we're succeeding? These are your metrics. What numbers move if the roadmap succeeds? Deployment frequency, mean time to recovery, infrastructure cost per transaction, customer-facing latency. If you don't have metrics, you don't have a roadmap, you have a wish list. There are 5 components to a technology roadmap. Each one is non-negotiable. The first is current state, the honest inventory. Include the embarrassing parts. The 5-year-old Java service nobody wants to touch, the manual deployment process, the monitoring gap. The second is vision, inspiring but achievable. Your team should read it and think that's ambitious, but we can get there, not that's impossible, or we're already there. The third is milestones, quarterly checkpoints. Each one delivers measurable value. If you can't demo it or show metric improvement, it's not a milestone. The fourth is dependencies. What must happen first? If you need a database migration before you can containerize, that's a dependency. If you need to hire a DevOps engineer before standing up Kubernetes, that's a dependency. And here's an important question. What's the most dangerous dependency? It's people. A roadmap that depends on hiring 3 engineers by Q2 when you haven't even started recruiting is a roadmap built on hope. Flag people dependencies early and loudly. The fifth is risks. What could go wrong? A key person leaves. Migration takes twice as long as expected. A vendor changes pricing. The board cuts your budget. A roadmap without a risk section is a roadmap that hasn't been stress tested. Executives will ask about risks. Have answers ready. This is the most important concept in the entire session. Everything else is technique. This is strategy. Every technology initiative must connect to at least one of 5 business goals. Revenue growth. Does this help us sell more, sell faster, or enter new markets? For example, an API platform enables partner integrations, which creates a new revenue channel. Cost reduction. Does this reduce infrastructure costs, reduce headcount needs, or eliminate manual processes? For example, CI/CD automation saves 20 hours per week of manual deployment work. Risk mitigation. Does this reduce the likelihood or impact of incidents, security breaches, or compliance failures? For example, SOC 2 compliance unlocks enterprise customers who require it. Competitive advantage. Does this enable capabilities your competitors don't have? For example, a real-time data pipeline enables personalized recommendations your competitors can't match. Customer satisfaction. Does this improve reliability, performance, or feature delivery speed? For example, reducing page load time from 3 seconds to 1 second increases conversion by 7%. Here's the key principle. If you can't explain the why, reconsider the what. If you're proposing a technology change and you can't connect it to one of these 5 goals in a single sentence, the proposal isn't ready. Don't say, it'll be better. Say, it'll reduce incident response time from 4 hours to 30 minutes, which means 97% fewer customer impacting minutes per month. ADRs are one of the most underused tools in software engineering. They capture the why behind a decision, the context, the options, and the trade-offs. An ADR is a short document, usually 1 to 2 pages, that captures a single architectural decision. Not a design doc, not a proposal, a record of a decision that was made. An ADR has 5 components. First, context. What's the situation? What problem are we solving? And what constraints exist? Second, decision drivers. What criteria matter? Performance, cost, team familiarity, maintenance burden. Third, options considered. At least 2 to 3 alternatives with pros, cons, and rationale for each. Fourth, decision made. What was decided, stated clearly and unambiguously. Fifth, consequences. What are the trade-offs? What do we gain? What do we lose? And what risks do we accept? The benefits of ADRs are substantial. For onboarding, a new engineer joins and asks why you use MongoDB instead of PostgreSQL. Instead of a 30-minute verbal history, you point them to ADR 007. 5 minutes later, they understand the context, the alternatives, and the trade-offs. For accountability, decisions have authors and dates, not to assign blame, to know who has context if questions arise later. For learning when a decision turns out to be wrong, and some will, the ADR tells you what you believed at the time. This prevents the hindsight fallacy. We should have known. No, given the information available, the decision was reasonable. For consistency, when a new team faces a similar decision, they search the ADR log first. Maybe the decision was already made. Maybe the context has changed. Either way, they're not starting from zero. For communication, ADRs are artifacts you can share with stakeholders. Here's the ADR for our database selection. It documents the alternatives we considered and why we chose this approach. Remember, ADRs are documentation of your architectural thinking, not your conclusions, your thinking. The reasoning process is more valuable than the result. Here's the template. 5 sections, keep it short. A good ADR fits on 1 page. First is the title. Keep it short and descriptive. Use PostgreSQL for user data is good. Database decision is not. Second is status. The life cycle goes proposed, then accepted, then potentially deprecated or superseded. Status tells readers whether the decision is still in effect. Third is context. Write it in paragraph form. What's the problem? What are the constraints? What's the urgency? For example, we need to select a primary database for the user service. Current requirements: 50,000 active users, expected to grow threefold in 12 months. Must support complex queries for reporting and transactional rights for user registration. Team has PostgreSQL experience. Budget allows for a managed service. Fourth is the decision. 1 or 2 sentences. We will use Amazon RDS PostgreSQL 16 as the primary database for the user service. Fifth is consequences. Split these into positive, negative, and risks. On the positive side, team already has PostgreSQL expertise, so there's no ramp-up time. The managed service reduces operational burden, and there's strong support for complex queries and ACGen transactions. On the negative side, RDS cost is roughly $400 per month for the recommended instance, and there's vendor lock-in to AWS, though that's mitigated by using standard PostgreSQL features. For risks, if growth exceeds the threefold projection, you may need read replicas or sharding. RDS has a max storage limit of 64 terabytes, which is sufficient for the foreseeable future. Of all 5 sections, context is the most important. A good context section lets anyone, including future you, understand why the decision was made, even if the technology landscape has changed completely. Due diligence is a structured investigation. It answers one question: is this technology, system, or team what it claims to be? There are 5 common scenarios where you'll need it. First, acquisitions and mergers. Your company is acquiring a startup. The CEO says their technology is amazing. Your job is to verify that claim. Is the code maintainable? Is the architecture scalable? How much tech debt exists? Are there security vulnerabilities? Acquisitions have happened where the acquired codebase was so brittle that the integration cost exceeded the acquisition price. Due diligence would have flagged this. Second, major vendor selections. You're choosing between 2 SaaS providers. Both claim 99% uptime. Your job: verify. Check their status pages. Read their postmortems. Test their APIs under load. Talk to their existing customers. Third, critical system integrations. Before integrating a payment provider, evaluate API documentation quality, error handling, webhook reliability, support responsiveness, and whether their architecture can handle your scale. Fourth, technology investments. Your CTO wants to invest $500,000 in a new platform. Your job is to assess: is the technology mature? Is the community active? Are there production success stories at your scale? What's the migration cost if you need to switch? Fifth, partner evaluations. A potential partner offers a joint technical integration. Evaluate their engineering practices. Do they have CI/CD? How often do they deploy? How do they handle incidents? A partner's technical maturity directly impacts your reliability. There are 5 areas to evaluate. Each gets a score. Together, they give you a comprehensive picture. Architecture: is the system scalable? Can it handle 10 times the current load? Is it maintainable? Can a new engineer understand it in a week? What's the coupling between components? Are there single points of failure? Red flags include a monolith with no service boundaries, no caching layer, no async processing for heavy operations, and no disaster recovery plan. Code quality. What's the test coverage? And where are the gaps? How much tech debt exists? What do static analysis results show? What are the code review practices? Red flags include less than 40% test coverage, no CI pipeline, no code review process, and deprecated dependencies with known CVEs. Security: has a penetration test been done, and when? What were the findings? Are there unpatched CVEs? Is data encrypted at rest and in transit? How are secrets managed? Is there an incident response plan? Red flags include secrets in source code, no encryption at rest, no security audit in the last 12 months, and no incident response plan. Team: what's the skills assessment? Can the team operate the system independently? What's the bus factor? How many people need to leave before critical knowledge is lost? Is there documentation? Are there runbooks? Red flags include a bus factor of 1, no documentation, critical knowledge in one person's head, and high turnover. Operations: how is the system monitored? What alerts exist? How are deployments done? What's the deployment frequency, incident rate, and mean time to recovery? Red flags include no monitoring beyond basic health checks, manual deployments, no rollback capability, and mean time to recovery greater than 4 hours. For scoring, rate each area on a scale of 1 to 5. Average the scores for an overall health score. Below 3 means significant investment is needed. Above 4 means you have a solid foundation. This is where most tech leads struggle. You can design a brilliant system, but if you can't explain it to the CTO in 5 minutes, it doesn't matter. The core principle is lead with the answer, support with details. Executives don't have time for your journey. They don't want to hear first we researched 5 databases and we benchmarked them, then we. They want, we recommend PostgreSQL. Here's why. Here's the cost. Here's the risk. Details go in an appendix, an IDR, or a follow-up email. The presentation is the headline. There are 5 questions executives will always ask. First, what's the business impact? Start here. Always. This migration enables us to enter 5 new markets, which represents $50 million in potential revenue. Now they're listening. Never start with the technology. Nobody outside engineering cares about Kubernetes. They care about what Kubernetes enables. Second, what does it cost? Total cost means people, infrastructure, opportunity cost from delayed features and licensing. Don't hide costs. Executives will find them, and if they find them after you've presented, you've lost credibility. Present cost alongside ROI. $200,000 investment. Projected $500,000 in annual savings. Payback period 5 months. Third, what are the risks? Name the top 3 risks and your mitigation plan for each. If you say no risks, you lose credibility. Everything has risks. For example, risk 1, migration takes longer than planned. Mitigation, phased rollout, starting with lowest risk service. Risk 2, team needs training. Mitigation, 2-week ramp-up period factored into timeline. Fourth, what's the timeline? Presented milestone-based, not day by day. Q1, containerize 3 services. Q2, migrate staging. Q3, migrate production. Q4, decommission legacy. Include what happens if the timeline slips. If Q2 takes an extra month, Q3 shifts, but Q4 remains achievable because of buffer. Fifth, what do you need from me? Every presentation to leadership should end with a clear ask. budget approval, headcount, priority alignment, or executive sponsorship. If you don't ask, you don't get. Many tech leads present beautifully and then forget to ask for what they need. Here's a 5-step presentation framework that works for executives, the board, and all hands meetings. Step 1 is the hook. Why should they care? You have 30 seconds. Connect to something they care about. We're losing $10,000 per day to manual deployment failures is a hook. I'd like to talk about our deployment pipeline is not. For a database migration, a weak hook is our database is old. A strong hook is our database has been the root cause of 4 out of our last 5 production incidents, costing us an average of 2 hours of downtime per incident. Step 2 is the problem. What's at stake? Quantify the pain with numbers, not adjectives. Don't say our deployment process is slow. Say our deployment process takes 4 hours, during which the team cannot ship bug fixes, and we've had 3 incidents caused by manual deployment errors this quarter. Step 3 is the solution. What do you propose? Be clear and concise. State what specifically you're recommending, not options, a recommendation. We recommend migrating to managed Kubernetes with a 3-month rollout plan. If you present 3 options and ask them to choose, you've delegated your job upward. Make a recommendation. If they disagree, they'll tell you. Step 4 is evidence. Why will it work? Provide proof points, industry examples, benchmark data, pilot results. Spotify migrated to Kubernetes in 2019 and reduced their deployment time from hours to minutes. We expect similar results based on our pilot with the notification service. Step 5 is the ask. What do you need? Budget, headcount, timeline, priority. Be specific. Not we need support, but we need $150,000 in infrastructure budget and authorization to dedicate 3 engineers for 3 months. Executives will push back. That's their job. Your job is to have answers prepared. When they ask, why now? They're questioning urgency. If you can't answer this, they'll delay. Would answers reference escalating costs, competitive threats, regulatory deadlines, key person risk, or compounding tech debt? For example, we can migrate now with 3 engineers over 3 months. Every quarter we delay, the migration becomes harder because new features are built on the legacy platform. In 12 months, the migration is twice the effort. When they ask, what if we don't do this? Present the inaction scenario. Don't threaten, inform. If we don't migrate, we project 8 more production incidents next year based on current trends, each costing roughly $15,000 in engineering time and customer impact. When they say, have you considered, they'll suggest alternatives. If you've evaluated them. Yes, we considered that option. We rejected it because of these specific trade-offs. If you haven't, that's a good suggestion. I'll evaluate it and follow up by Friday. Never dismiss their suggestion or get defensive. They may have context you don't. When they ask, what's the ROI? Have this number prepared before you walk in. Cost versus benefit payback period. Investment, $200,000. Annual savings, $500,000 from reduced incidents, faster deployment, and lower infrastructure costs. Payback, 5 months. If you can't calculate ROI, at least calculate the cost of inaction. When they ask, what could go wrong? Present your top 3 risks with mitigations pre-prepared. Don't improvise risk assessment in front of executives. The golden rule. Prepare answers before you present. Every one of these objections should have a rehearsed answer in your notes. The worst moment in a presentation is silence after a tough question. Here's the scenario. Think of it as a brief from your CTO. The current state, a regional e-commerce platform with monolithic architecture. 1 code base, 1 deployment, 1 database. 2 million monthly active users, 25 engineers, $50 million in revenue. It works, but it's showing cracks. The growth goals. The board has approved international expansion. 5 new markets in 18 months. Launch a B2B wholesale platform alongside B2C. The target is 10 million monthly active users and $200 million in revenue within 3 years. Think about what breaks first when you try to 5 times a monolith. Deployment velocity grinds down with 25 engineers blocked on 1 pipeline. Data residency becomes an issue when GDPR requires EU data to stay in the EU. Latency suffers when serving users across continents from one region. And localization gets complicated with multi-currency and multi-language requirements. The constraints are real, our $2 million budget. You can hire 10 engineers per year, not 50. GDPR and data residency requirements apply for EU expansion. You can't re-architect everything. You can't hire a massive team. You need a phased approach that delivers value incrementally within a limited budget. The challenge asks you to produce 4 deliverables. First, a technology roadmap, a 3-year vision with quarterly milestones. Second, an architecture decision record, one key decision such as microservices versus modular monolith. Third, a due diligence report, an evaluation of the current platform's readiness for expansion. Fourth, a stakeholder presentation, a 5-minute pitch of the roadmap to the CEO. Here are the 5 steps to build your roadmap. Step 1. Define current state honestly. List every piece of technology, languages, frameworks, databases, infrastructure. Then list the problems, deployment frequency, incident rate, known tech debt. Be brutal. Step 2. Articulate your 3-year vision. Where should the platform be in 3 years? Multi-region, microservices, B2B platform live. Define it concretely. Step 3. Identify quarterly milestones. Each quarter delivers measurable value. Q1 might be containerize the catalog service, deploy to EU staging. Q2, go live in the first EU market. Step 4, map dependencies and risks. What blocks what? If you can't hire EU-based engineers, multi-region deployment is harder. If the monolithic database isn't ready for sharding, you can't split by region. Step 5, connect everything to business goals. Every milestone maps to revenue, cost, risk, or competitive advantage. If a milestone doesn't connect, question whether it belongs on the roadmap. And 5 things to remember from today's session. First, roadmaps align technology with business. The roadmap is your primary communication tool. It bridges the gap between engineering plans and business strategy. Second, ADRs capture architectural thinking. Start writing ADRs immediately, even for decisions you've already made. Future engineers will thank you. Third, due diligence is systematic, not ad hoc. Use the framework. 5 areas scored. Don't rely on gut feel. Fourth, executive communication is business first, led with impact, not technology. Always. Fifth, anticipate questions before presenting. For every slide, ask yourself, what will the CFO ask? What will the CTO push back on? What's the objection? Have answers ready. There are 4 deliverables, each worth 25 points. The technology roadmap, current state, vision, milestones, risks, and metrics. Does it connect to business goals? Is it achievable within the $2 million budget and hiring constraints? The architecture decision record. Pick the most important decision for the expansion, such as microservices versus modular monolith or multi-region strategy. Follow the template. Document alternatives and trade-offs. The due diligence report. Evaluate the current platform against the 5 areas: architecture, code quality, security, team, and operations. Identify gaps that must be addressed before international expansion. The stakeholder presentation. 5 minutes. Hook, problem, solution, evidence, ask. Present as if you're speaking to the CEO and board. They'll ask the tough questions we covered earlier. Passing is 75%. Exceptional is 90 or above. The expectation isn't perfection. It's evidence of structured thinking, clear communication, and honest trade-off analysis. Here are the key resources for further study. Staff Engineer by Will Lawson is the definitive book on senior IC and tech lead roles. Pay special attention to the chapter on being visible. It covers the communication skills we discussed today. There's a widely used ADR template on GitHub by Joel Parker Henderson at the Architecture Decision Record repository. Fork it for your team and start using it immediately. The ThoughtWorks Technology Radar is published twice a year. It organizes technologies into adopt, trial, assess, and hold categories. Use it as input for your roadmaps and technology standards. Fundamentals of Software Architecture by Richards and Ford is shared reading across the architect track. Focus on the chapters about architecture characteristics and trade-off analysis. Let's reflect on 3 important questions. First, how do you currently communicate technical decisions? Many teams rely on Slack messages, verbal conversations, or conference pages. But consider this: how do you communicate decisions to someone who joins the team 6 months later? This usually reveals the gap. There's no durable record. ADR solves this. They're searchable, version controlled, and outlive any individual. Second, what's missing from your team's architectural documentation? The most common answer is either everything or we have docs, but they're outdated. The problem with documentation is maintenance. ADRs work because they're write-ons. You don't update an ADR, you supersede it with a new one. The old one becomes history, not liability. Third, how do you balance short-term delivery with long-term vision? This is the hardest question. The answer is never 100% features or 100% tech investment. The answer is a ratio, typically 70-30 or 80-20. That's explicitly agreed upon with product management. If the ratio is implicit, tech investment always loses. Put the ratio on your roadmap. Q1, 70% feature work, 30% platform investment. Now it's a commitment, not a wish. That wraps up month 1 on strategic architecture. In month 2, we'll cover people management, one-on-ones, performance reviews, giving feedback, and building teams. The other half of tech leadership. Today we covered the introduction to strategic thinking as a tech lead, technology strategy including roadmaps, ADRs, and due diligence, strategic planning through the workshop exercises, and the presentation framework for communicating your plans. A few common questions worth addressing. How long should an ADR be? 1 page. If it's longer, split the decision into multiple ADRs. If it's shorter, you might be missing the context or consequences. How do you convince your team to adopt ADRs? Don't ask permission. Start writing them for your own decisions. When someone asks, why did we choose this approach? Point them to the ADR. Once people see the value, adoption happens naturally. What if the CEO rejects your roadmap? That's actually a successful presentation. You've surfaced a misalignment early. Ask what concerns them and what they would change. Iterate. A rejected roadmap is a conversation starter, not a failure. How detailed should a due diligence report be? Detailed enough to make a decision. If you're recommending an acquisition, the report needs to justify millions of dollars. If you're evaluating a library, a half page is fine. Match the depth to the stakes. Thank you and good luck with your deliverables.